Welcome everybody to this meeting from the Sports in Statistics section of the RSS. My name is Dr. Rob Mastro Domenico and I am Vice Chair of the Sports section. Today we've got two excellent talks. So any of you came to the conference, well, you should know by what we put out on it. You will have seen these two gentlemen as they were the first and second place entrants in our Euro 2020 predictive analysis competition. And what we wanted to do is, because the talks were so good on the day, and at the time when we did this conference, there was this little thing called COVID going on. So we maybe didn't have the attendance that we wanted for this. So at the time after doing the session, we said, we're going to do something else with you. And we wanted to kind of link this to our Wimbledon 2020 predictive competition. That at the time, we didn't know what we were going to do it on, but we knew we went so well last year, we wanted to do it again. So the purpose of this session is to kind of let them talk to you about what they did, hopefully whet your appetites about getting involved in this competition, of which I'm going to tell you more about. But also, so we've got something to kind of keep forever, just to say, you know, these are the guys, this is our first and second place winners. So we can refer back to this. So we'll be promoting this on our Twitter. This will be on the RSS YouTube. And we can kind of use this as an example of kind of what the whole competition is about, because there was two very different methods, both very good speakers and very interesting talks. But you didn't come on here to listen to me talk about them. You want to hear them do their talk. So today we've got Ian Hamilton and Matt Penn. I'm going to let them talk more about themselves and they can kind of give you a background into what they're doing. But we're going to first start off with Ian. So I'm going to hand over to you. I'm going to turn my camera off and mute myself. The floor is yours. Share your slides, and I look forward to seeing your presentation again.
Hello everyone. Right, let me share my slides. I slightly changed the title from what I did before, just to give it a bit of a different emphasis. So the method that you'll see me presenting today is super simple. So I hope that inspires some of you, even if you don't have so much time to put into this, to think that you can do something nevertheless. So the title I took for today is How to Predict Euro 2020 with 120 data points and 2 linear regressions. And when we came to this competition, sorry, I should say this was a project I did alongside my colleagues Stefan Stein and David Selby. So we have all been PhD students at the University of Warwick. I still am. Stefan and David have moved on. And when we came to do this, the initial motivating ideas behind this, well, the first one was that a significant proportion of the competition outcome would be luck. So the point there being that if we got an entry in, then we would have at least a chance, and probably a pretty decent chance, of getting a trip to Manchester, which seemed like a good thing to do. The second was that we didn't have much time. So as I recall, we had to get the predictions in by 8 p.m. on the Friday of the tournament, before kickoff of the first match of the tournament. And I think we started discussing it on the Tuesday, so we really didn't have too much time. We also had other things on in those few days, so it had to be something fairly simple and straightforward as an idea. The third thing was markets are good at evaluation. So my background before I came back to university to do a PhD was in trading in the financial markets. And so I felt that there was value and information in the market odds, and we should use that. But at the same time, that experience had also taught me, my fourth thing, that markets sometimes get things wrong, and in somewhat predictable ways. So if there's anyone here who is enamored of the efficient markets hypothesis, they might be jumping up and down right now, but I'll come to what I mean by that. So what we decided to do was to take as our data, instead of match outcomes, as I think all the other entries did, what we took were match odds, the market odds. So the structure of the Euro 2020, for those of you who don't recall, was that you have an initial group stage with groups of 4 with an all-v-all round robin tournament there, and then teams progressing into knockout stages. So for those group stages, we just took the market odds that were available. Now, this shows Odds Portal. I can't remember whether we took our odds from Odds Portal or somewhere else, but you can find the odds fairly easily online. And because these markets are quite liquid, the odds from the different sources will tend to agree quite well, but there may be some are better than others. That wasn't something we looked into. So for those initial round matches, we just straight took the market odds, but we still had this problem of how are we going to construct the odds for those matches that happen in the knockout stages, because these we didn't have those. The market hadn't put odds to those because they didn't know which matches were going to be happening. So for that, we turned to a model, and the model we turned to is the Bradley-Terry model. And in the Bradley-Terry model, it's a beautifully simple model in a way. The probability that a team I beats a team J is equal to pi I over pi I plus pi j, where pi I is the strength of team I, or can be thought of as the strength of team I. We can also represent this as a generalized linear model. So the logit of Pij equals lambda I minus lambda j, where lambda I is equal to the log of pi I. And this is a model that was initially published by Zermelo in 1929, and unfortunately for him, he published it in German, and so Bradley and Terry came along in 1952 and independently rediscovered it and got it named after them. Now, the typical use for a Bradley-Terry model in something like sports prediction would be to fit the past performance data and estimate the parameters based on that. So you would have a model like this, your likelihood represented here, and you use maximum likelihood estimation to estimate those pi I or lambda I parameters. And that's sort of what I recommend a website here, alt3.uk, which is produced by my supervisor, David Firth. Now, he's not predicting things there. He's using this as a retrodictive model. So what that website does is it looks at the results mid-season and says, if you take account of the fact that some teams have had more difficult schedules than others, have played stronger teams, some have played more home than away, some have played more matches than others. If you take account of all of these in a principled way that is consistent with a round robin ranking, then what kind of league table do you get? And that can have quite material differences. A classic example would be that way back when Ronald Koeman was fired as Everton manager, I think he was something like 16th or 17th in the table, as you would normally look at it, whereas he was 11th or 12th when you made these sort of adjustments. And you kind of wonder whether the Everton board might have had a different reaction had the Everton they'd been seeing every day in the paper and whatever, Everton at 11th or 12th. In any case, that instance of Bradley-Terry, using the Bradley-Terry model, is applying it to a set of results. But in this situation, we didn't feel that was a great thing to do, because there weren't enough recent useful results. So obviously you had the group stage matches, the qualifying matches for the tournament to do it on. But then you were confined to little groups. You had friendlies between teams in other groups. You might have had some older competitive data that you could use, but that win-loss data was not really rich enough to, we felt, build good estimates on. We felt the market prices were likely to be more informative. You behind those market prices, you have a whole industry and a lot of money and a lot of people trying very hard to get those prices right. So we felt they were likely to be more informative. The other problem of using the Bradley-Terry model, as you might have spotted, it didn't take account of draws. So I'm going to deal with that last one first. So you can build draws into the Bradley-Terry model, which was a proposal initially by Davidson in 1970 and then updated by David Firth to account for the fact that in modern football we have 3 for a win, 1 for a draw. So this power of a third here in the Davidson model is a half. Taking it to be a third means that you have agreement with a round robin ranking on a round robin set of results. But an important thing to note for our usage of it is, even if you allow for the draws in this through this model, the ratio of Pij to Pji is still equal to the ratio of the strengths. So even though Pij plus Pji does not equal 1, that ratio is still true. So we've still got the logit of Pij equals lambda I minus lambda j. And the point here is that Pij is a value that we know. We can, or at least for some combinations of I and j, we know it because we've got those market odds for those preliminary round, those qualifying round matches. So within those qualifying round matches, the first stage of the Euro 2020 tournament, we can estimate intra-group strengths just by taking our PIJ and PJI, which we can see from the market, and fitting a linear regression. So there's our first linear regression. So we get these intra-group strengths, RI and RI for each team, but they're not linked up. So we don't know if a value of, I don't know, 2 in one group is equivalent to a value of 2 in another group. So how do we go about comparing those strengths across groups? Well, we make 2 assumptions. So the first assumption we make is that Team I's overall strength, pi I, is a scaling of its intergroup strength, SI, by a factor dependent on its group, i.e. each of the whole tournament strengths, pi I, as I referred to it here, is a product of its intergroup strength and what you might think of as the strength of the group, this gamma G of I. Or equivalently in log terms, the lambda I, our tournament strength of the team, is equal to log of gamma G of I plus Ri. The second assumption we make is that the strength of every team's unknown final opponent is the same. So we're thinking about, if they got to the final, how strong would that opponent be? And we say, well, for everyone, it would be the same. And that's probably a pretty decent assumption in a tournament like Euro 2020, and also I'd say in Wimbledon 2022. Where it might fall down would be if you had a tournament where you had one player that was a lot stronger than all the others, then it might be reasonable to think that the strength of opponent that they would play in the final would be less than the strength of the opponent that anyone else would play in the final, because anyone else would likely play that very strong opponent. But for this situation, that seems like those both seem reasonable assumptions to make. And with that second one, what that allows us to do is use the fact that we do have market odds for both the probability of I winning the tournament and the probability that I reaches the final. Now, in theory, we had those for all teams. In practice, some of them were so low, these probabilities, that you got very dodgy estimates for PI 0 here. So what we chose to do was just to use the ones that were kind of credible, that weren't just noise. But using that, then we can, those data, we can estimate now our the value of the gamma GIs, and as a parameter we throw away the value, the strength of the final opponent team. But what that enables us to do is to get those group strength parameters. And so given those group strength parameters, we now have the strengths of every single team. So obviously we're just doing another linear regression here, and obviously on both those linear regressions you got your standard assumptions, which we didn't think too much about. So we've got our overall strength for each team, and then we can simply use the Bradley-Terry model again to combine those to get a probability of either team winning, which is what we used for the knockout stages. So some notes to make on this. Firstly, that this is a very parsimonious model. We predicted all those matches, and I can't even remember how many there were, but what we had 24 teams, so you've got around I'm trying to do some mental maths here, it's going to go wrong, nearly 500 matches, and we predicted those from 120 data points and 2 linear regressions. So that's pretty decent, and in 2 days. Secondly, I mentioned at the start, you may remember, that we were going to use the market being wrong in somewhat predictable ways. Well, the idea there was, if you have a market where not all the betting is based on pure objective evaluation of the situation, but some of it is led by the heart rather than the head, then if that is happening in a somewhat predictable manner, then you might be able to adjust that to get to something, the head level predictions. So actually, if you look at European betting patterns, the UK is responsible for a very vast proportion of betting, and so it might be reasonable to think that the odds on England flatter England in the sense that they give them too much of a probability of winning. And if that were the case, then you might want to adjust that out. So our original plan was to look at that in a historic sense, to what degree that was true, and reduce the England probability a bit. Fortunately for us, we didn't get time to do that, and obviously England did very well. So it was a piece of luck that we didn't get to apply that. The third thing, actually, just before I get to the third thing, I haven't mentioned that I did this with my two colleagues, Stefan and David, and one of the things with the time constraints was that was very helpful. We were all able to bring something to the table. In particular, they're better coders than I was, and with the time constraints, it made it much easier to get the thing done. So if any of you are thinking of doing it, it can be quite a nice thing to do from a team perspective. But anyway, getting on to the final point on this slide, did we do well just because of taking market odds for the group stage? So one objection I would have seeing this presentation is, okay, you did well in this tournament overall, but frankly, you kind of, don't want to use the word cheated, it was within the rules, but you just used the market odds for the majority of the matches. And that's true. But, and I wondered if that was true. But if you look at what this is the accumulated log loss for the 4 teams that came in the top 4 positions. So our team was BTGH, the orange line here. And if you look at those results just for the knockout stages, we still came second. So there was something we were onto that was more than just taking the market odds. The other interesting thing, a couple of things to mention here. One is if you look at how much the results deviate between the teams, they don't very much. So you'll see at, I mean, I'm not sure, these is a very poor thing. I think I haven't labeled the axes here. I think this is sort of game weekends or something, or approximately something like that. You remember in Euro 2020, you'll have a group of matches happen within a couple of days. So and this is each of those, the labeling on the x-axis. So you'll see going from 3 to 4, you had that deviation. So that was a day where Matt's prediction model did a much better than ours. But I think that's the only instance of it. And otherwise, they're remarkably consistent, despite very different methods, as you'll see. The second chart here, what I've said, market calibration, absolute log loss difference. What this is actually doing is comparing our predictions, the predictions of all the top 4 teams, against the predictions that you would have had from the markets immediately prior to those matches. So we've made our predictions before the tournament. So without any of the information of how the teams have done in the tournament up to the point of those knockout matches. And we're comparing that in this chart with how the market did in assessing those odds in those knockout stages. And actually, not clear because I haven't labeled it very clearly, but all of us beat the market, which I think is really interesting. And the final thing I would mention in relation to the title of this slide, how much was luck? Well, actually, as you see, the performances are fairly consistent. It's not like the relative performances were dinging around a lot. So I actually think maybe there was more skill or a different kind of luck maybe involved in this prediction competition than I thought there was going to be. Right, so to get on to just quickly what this might have relevance for what you're thinking about doing in Wimbledon 2022, hopefully. Might ask 3 questions. So 3 questions you might ask. Can I use the same method to predict Wimbledon 2022? 2, can I use the Bradley-Terry model to predict Wimbledon 2022? And 3, can I use market odds to predict Wimbledon 2022? And I'll take those as 3 different questions. So first answer, can I use the same method to predict Wimbledon 2022? Well, strictly no, because there isn't the round robin tournament. So you don't have that forward set of results other than the very first round, but that first round doesn't give you much of a network at all. It just gives you pairs, individual pairs. So based on just the Wimbledon odds, you couldn't do this method. However, you could do something that uses other recent grass court tournaments. So coming into Wimbledon, there are a series of grass court tournaments. So Stuttgart, Eastbourne, Brighton, Queens, Nottingham, Birmingham, I think Halle. So you could take those and use those as your matches to get the relevant odds and use that method. Now it might be doesn't work quite so well because obviously you're missing the most recent piece of information, the result from any of those last matches, and those aren't in the prices that you saw before. So you might be missing a bit of information, but I think it would be kind of possible. I also suspect if you've got players who weren't in any of those tournaments or got knocked out very early on, you might want to augment your data with things like world rankings or the outright odds for players to win the tournament or to progress to a particular stage to come up with your win-loss probabilities. But more or less, I think you probably could adapt the method to work for Wimbledon 2022. Second, can I use Bradley Terry model to predict Wimbledon 2022? So you'll remember that I said you could use it in a more conventional way to look at match results and infer a strength of each team based on those match results. So you could do that. I think that's probably not a great way because tennis is obviously very dependent on things like surface and you're not going to have very many results. But what you could do, which I think is interesting and probably would work quite well, is to use the Bradley Terry model, but on a points basis. Now, obviously, when you start to think about that, you'll probably think, well, even then I need to take account of who's serving, who's not serving, and there's ways of doing that. You might want to incorporate other factors. You might want to use more data than just grass court tennis, and therefore you want to incorporate what surface it's on. And you might want to have some consideration of form, so some sort of recency weighting in it. So there's various ways you can do it, but absolutely you could build a model based on the Bradley Terry model, and I don't think that's a terrible idea. Can I use market odds to predict Wimbledon 2022? So what I mean here is, other than what I was suggesting with the method that we showed for Euro 2020, well, yes, I think you can, and you probably should, in that they contain, as I put here, blood, sweat and tears and experience of many highly intelligent and motivated analysts. So there's a lot of information in the odds themselves. There's all those models that people have spent hours and hours building up. So if you're not using them, then you're throwing away a lot of information. Now, with unlimited, well, maybe not unlimited time, but a lot more time than I have, then I think what I would possibly be looking at doing is building a model based on outcomes, probably point-based outcomes, and building a model based on the market odds, and then looking at what are effective means of combining those independent models. I think that could be a really interesting approach. So absolutely, I think you can look at models where the market odds themselves are the output variable on which you train or fit your model. So with that, I am done, Rob.
Fantastic. Sorry, I did hear you earlier, but I couldn't find my unmute button, so sorry. Thank you, Ian. Any questions we'll do at the end for those of you who are on the call a bit later. So if you think of any, you can raise your hand at the end. You can ask them yourselves or stick them in the chat and I will ask them. But we will now hand over to the winner of the predictive competition, Matt. So over to you.
Great, thank you. Cool, let me just share my screen. There we go, hopefully everyone can see that. Do shout if you can't. So I'm Matt. I'm a first year PhD student at the University of Oxford. And yes, this was my I did this prediction competition in the summer between undergrad and postgrad, so I had lots of time to kill and spend on all these fun things. So I'm just going to talk through the method that I used to make this model. So it's based on Poisson processes and then maximum likelihood estimation, like Ian was talking about. We'll characterize each team by an offensive strength and a defensive strength, and that will allow us to derive probabilities of the various results. We'll then assess the accuracy of the model based on what happened in Euro 2020, and if we have time at the end, we'll quickly look at how you can combine everything into one single parameter for each team to give you a simple way of ranking the different teams. But to start with, we need a way of modeling goals scored in football games. So let's just suppose that the inventively named Team A is playing against Team B. I'm sure they're arch rivals. And we'll characterize their goals by these kind of means. So mu AB will be the mean number of goals that Team A scores against Team B. And similarly, mu BA will be the mean number of goals that Team B scores against Team A. A common approximation in modeling football matches is to assume goals are scored according to a Poisson process. So that just means that kind of goals are scored at a constant rate by each team and that goals are scored independently of each other. It's not a great assumption. Often if you score a goal, then there's quite a high chance of there being another goal in quick succession. But it's not awful over the course of a whole game. So that just means that our total goals scored are Poisson distributed with these means we talked about before. Maybe in an ideal world, you'd like to estimate all of these means kind of individually, but there's lots and lots of terms. Like if you've got, I think, 55 European international teams, then you've got 55 times 54 of these mu terms. And so to reduce the number of things that we need to estimate, we're going to assume that they're just a function of offensive strengths and defensive strengths of the relevant teams. And a simple way of writing that relationship is to assume that they're linearly related. So we've got this equation 3, assuming that mu AB is just a linear function of OA and DB. We can kill some of the terms by saying that if a team has no attacking strength, then they will score no goals. And so that gets rid of our gamma and our delta terms. And the final two coefficients can just be removed by scaling. And we end up with this nice equation, equation 7, where we just have the product of the offensive strength and 1 minus the defensive strength. And just to make things a bit clearer, we'll define a defensive vulnerability. So VB is 1 minus DB. And that gives us this really nice product form for the mu ABs. To make further progress, we need some data, as much as I was tempted to just kind of randomly pick how good I thought all the teams were. And for that, I used international football results from between July 2018, so just after the end of the 2018 World Cup, through to June 2021, when I had to submit the predictions for the competition. The data set was restricted to matches where both teams are European. You could, in theory, create a whole worldwide model, but there's so few games that are intercontinental that it's not really worth the extra noise to include those extra teams. But European teams not playing in Euro 2020 are included. That massively increases the number of games that we have in the data set and does give us a lot of useful information about Euro 2020 teams. And I'll go through very quickly the way to estimate the parameters, which is through maximum likelihood estimation. So to start with, remembering our kind of goals are scored according to a Poisson distribution. The probability of Team A scoring X goals against Team B is just this e to the minus mu AB times mu AB to the X over X factorial. And then because we're assuming that everything is independent, we can combine all of our different results together in one huge product to get the likelihood. So if we just define M to be the set of all of our matches, then this first bracketed term here is the number of goals that the home team scored in match N and the likelihood of that. And then the second bracketed term is the number of goals the away team scored in match N and the probability of that. As is then standard in these kind of likelihood arguments, we take the logarithm to turn our product into a sum, and then just differentiate with respect to each of the variables and set those derivatives equal to 0. So we end up with these two slightly horrible looking equations for our parameters. And these are obviously taken over all A and all B for all of the teams. We can do some simplification, thankfully. So if we define this matrix P to be the number of matches played between each pair of teams, and these vectors F and C to be the total goals scored and total goals conceded, summing all the relevant terms in the equations gives you this much nicer pair, which is much easier to deal with. An important note, and this is something which I didn't do at the time, is it's helpful to multiply up these equations by the OA and the VB respectively. That's because your computer is going to struggle with this 1 over OA term if OA becomes really small when it's trying to solve it. And this just helps make everything more stable. And it's good to know after doing a lot of maths, and if you're anything like me, probably having made lots of mistakes, that these equations make sense. So if we look at this equation over here, we can rewrite this in this form and see that this is just telling us that the expected number of goals scored by A under our model is going to be set equal to the total goals scored by A. And similarly, this other equation will give you the expected goals conceded by team B is going to be equal to the number of goals conceded by team B. So these are good like moment matching equations. Once we've got our parameters, we can then calculate win, draw, and loss probabilities relatively easily just by using our Poisson distributions. The couple of complications are that in the knockout phase, games go to extra time. And so it was assumed that the number of goals scored in extra time was just a third of the number of goals scored in normal time. Well, the distribution had a mean equal to the third. And this proved to be a relatively accurate assumption looking at the games across Euro 2020. And then finally, it was assumed every team was equally likely to win in a penalty shootout. Obviously, that's not true in the case of England, but they're only 1 out of 24 teams, so it wasn't worth correcting the model in that way. A couple of notes on the equations. First of all, you'll notice that OA and VB themselves aren't uniquely defined. So we can, for example, multiply all the OAs by some parameter rho and divide all the VBs by that same parameter rho. And then that gives us a new solution to the equations because we've only ever got these OA times VB terms. But under fairly general conditions, there is a unique solution for mu AB, which is really all we care about. These OAs and VBs are measured in pretty arbitrary units. But this uniqueness for mu AB is crucial for the reproducibility of the model. If there wasn't a unique solution, then you'd end up just kind of converging to whatever solution your solver converged to, and there'd be lots of kind of equally likely sets of parameters. Or even worse, if there wasn't a solution at all, you'd just get some random set of parameters spat out where your solver gave up and discovered that there wasn't a solution. And if you're interested in the proofs and the exact conditions, then you can find them in this paper referenced here. So the second problem with the model is that if you have a team with very high defensive vulnerability, you can end up skewing the data quite a lot. So if we imagine that team M has very high defensive vulnerability, then if A has played against M, so if PAM is bigger than 0, then these model equations here, the VM term is going to dominate this sum. And so we end up with the equation FA is roughly equal to OA times PAM times VM. And then things get even worse if you kind of take the limiting case. So if team M is really loads worse than all the other teams, then most of the goals team A have scored will be in their matches against team M, which you remember is kind of given by GAM. And so then this FA is replaced by GAM, and to leading order, you get an equation for OA, which only depends on the result between team A and team M. And this is really problematic because really GAM is not going to depend too heavily on OA in reality. If you imagine an international football team playing against a team of 10-year-olds, it doesn't matter whether it's Slovakia or it's Spain. They're both going to score an awful lot of goals. And the exact number of goals that they score is going to be relatively random and not depend on the fact that maybe Spain are a bit better in attack than Slovakia. And this did cause quite big problems in the original data set. And to combat this, the games involving San Marino were removed. And we can see the effect of removing these games. So this graph shows the percentage change in the attacking strengths OA of different teams after San Marino were removed. So I think this is all the teams that changed by at least 2% or something similar. There's some big decreases. So in particular, Cyprus, Moldova, and Kazakhstan. And this is because they scored a large percentage of their goals against San Marino. So for example, Cyprus scored 9 goals against San Marino in their 2 games. And that was 36% of the total goals they scored across the 27 games they played in the data set. So you can see how that's going to skew the data quite a lot. Similarly, the attacking strengths of Belgium and England increased after removing San Marino. And this is because, according to the model, they were expected to score an average of around 9 goals per game in their games against San Marino. And while that's possible, like England did put 10 past them not too long ago, it's quite unlikely. And the fact that Belgium and England averaged, I think, about 6 and 5.5 goals against San Marino doesn't show that they were like 10% weaker in attack than you'd otherwise imagine. The only negative effect of removing San Marino is in this increase to Gibraltar's attacking strength. So Gibraltar only scored 1 goal against San Marino, which really does show that they're maybe not that great in attack. But because that kind of effect is only going to happen for the really weak teams, it's not something we need to worry about too much when ultimately we only want to model the teams playing in Euro 2020. But yes, now we can look at the results after removing San Marino, and this is a kind of scatter plot of the attacks and the defenses of the different teams. And so you can see it's roughly what we'd expect. So Italy have the strongest defense. Belgium and England, remembering this is before England forgot how to score, have the highest attacks. And then most of the other main contenders are roughly where you'd imagine them to be. And now let's move on to comparing how the results actually did. And so one of my big concerns when I was making this model is that the games that the data was taken from, so qualifiers and Nations League games and friendlies, might just have a different kind of vibe to the games in Euro 2020, where there's loads of pressure on the teams. So it would be possible that, for example, the average number of goals in friendlies was much higher, or the average number of goals in qualifiers was much higher. But actually, we can see that overall that didn't really happen. So the model predicted that the number of goals scored in Euro 2020 would have a mean of 145.8. And that actually aligns really well with the total number of goals scored, which was 142. So that's definitely a good sign that the games that this model are based off are representative of tournament football. We can also look at the goals scored on a team-by-team level. So this graph shows the predictions versus the actuals for each team, and we can see that they fit really well. So the total explained variance is 0.83. And yeah, just looking at the graph, most of the dots are quite close to the top of the bars. The one big difference is in England. And that's because England played a lot more defensively in this tournament than maybe people would have predicted. And that is a disadvantage of using old data. It's always going to be out of date, and it's not going to be able to take into account any kind of tactical changes. Goals conceded fit a little less well. So there's quite a few big deviations here. Particularly England, again, conceded a lot fewer goals than would have been expected. And also the Czech Republic, who we'll maybe talk about a little bit more later, really did much better in the tournament than the model predicted. And there's quite a few big deviations in other teams. In terms of actually predicting the results, so according to this model, the results of Euro 2020 had a total log likelihood of minus 39.33, which aligned relatively well with the expected log likelihood according to the model. So that was minus 40.98. And running the numbers and kind of doing a hypothesis test, there's not really a significant difference between the actual log likelihood and the expected one. And we can also see that the probabilities were kind of well assigned across the board. So one concern when making these models is you might overpredict the chance of the chance of a strong team beating a weak team, or you might underpredict the chance of a weak team beating a strong team. But this table kind of shows that it didn't happen in a hugely noticeable way. So for example, this first row shows that of all of the possible results, the model put 60 in the 0 to 0.25 probability bracket. And of those 60 results, 0.17 occurred. So 17% of them occurred, which is perfectly within this 0 to 0.25 range. And that's kind of consistently true across the board. One of the things which I really didn't think very hard about, and probably should have before making this model, was how to choose the time interval of the data set. So it's fairly obvious that you want to have the data set going as recently as possible. That's not difficult. You want your data to be as new and as relevant as possible. But choosing the start date is a little bit more complicated. And this graph kind of shows what the model would have scored. So what the log likelihood would have been had the start date been at all of these different times. So you can see kind of as you go further back in time, you're putting lots of kind of irrelevant data into your data set, or not necessarily irrelevant, but it's not quite up to date. And so your log likelihood is much lower, which is worse. And then as you make the start date of your data set kind of newer and newer and newer, your log likelihood increases until eventually you reach this kind of noisy phase over in the kind of 2019 to 2020 region where you just haven't got enough data to make sensible predictions. And as it turns out, the choice of kind of just after the World Cup was not quite the best, but it was close enough to the best possible choice, which was quite lucky, really. And yeah, so it suggests that maybe going from the previous tournament is a good general principle for these things. Obviously, in a non-COVID world, there would have been fewer games between World Cup 2018 and Euro 2020. So perhaps if you were looking to predict Euro 2024, you'd need to maybe make your data set kind of go back slightly before the previous World Cup. But yes, overall, it seems that's about the right kind of length. There are, however, a lot of improvements that could be made to the model. In particular, you could replace the underlying Poisson process of goals. So there's been a few papers published which have suggested that this underpredicts the chance of low-scoring draws. And so various people have tried to make modifications to it. You could also include the effect of home advantage. So that was a bit messy in some of the data set that I was looking at because of COVID and the fact that crowds weren't there and home advantage disappeared to a certain extent. But that would be something that would be very beneficial to include. You could also weight matches differently in a data set. So international teams do change quite a lot over the course of a few years. And so giving more recent matches a higher weight is possibly a good idea. So in particular, the Czech Republic, who the model really underpredicted in the tournament, they'd had a really good run in 2021 and the end of 2020. And so that might have picked up that there was a good generation of Czech players coming through. And you could also discard matches against a wider range of weak teams. But just finally, I think we've got time just to kind of think about how to write down a team strength for the teams. So if we look at this inequality, so the probability that A beats B being bigger than the probability that B beats A, you can actually rearrange this into something which has all the terms of A on one side and all the terms of B on the other. And this gives you a really natural definition for the strength. So SA being equal to OA over VA. On their own, the strengths aren't enough to calculate the probabilities of each result, as if you kind of make OA and VA really, really high, then you're going to have more goals in your game than if they were low. And so therefore a draw becomes much less likely. But it does give us a good way of comparing teams kind of with a single parameter. And very satisfyingly, if you look at the ranking for the teams in Euro 2020, we find Italy in first, England in second. Switzerland, who surprisingly beat France, were actually ranked slightly higher by this model. And then, as I mentioned earlier, Czech Republic were really ranked quite lowly, did much better than the model would have thought. But yeah, if you are interested in any more of the maths, then you can find them in this paper I referenced earlier. If you'd like to find the code, then it's available on GitHub. And the data that I use is also available on Kaggle. It's a slightly misleading URL. This data is actually updated relatively regularly, so it does go all the way through to 2022 now. But yeah, that's pretty much me done. I guess hand back to Rob.
Thank you. Yeah, great talks, guys. Thank you very much for those. If you can both have your cameras on, that's great. Do we have any questions for the speakers from the audience? Don't rush it all at once. Yes. Do we have a question? Nice. That was more of a point from Ben. Anybody got any specific questions to ask? Otherwise, it's down to me to ask the questions. Cool. Well, guys, they're really good, interesting when we saw these in September, and they're interesting now to see the talks again. Are there any points from each other's talks that you look at and say, maybe I should have used that, or that's interesting if I incorporated that into what I did? Were there any kind of, because you all came into it blind as well when we did these talks, you hadn't even met each other back in September. Were there any things that you kind of took it away from each other's that you thought, well, that's actually quite interesting? Because you approached them very different kind of ways. I think both are sensible, and it shouldn't be like disregarded the amount of variation that there is in a tournament like Euro 2020, and the fact you were able to predict that really well, and like Ian said, beat the market, which is really, really impressive. Were there any specifics you kind of took from each other's? If you were doing again, you might change?
I think for my part, I was really surprised because I'd been monitoring how close the results were as we went along between our model and Matt's model. And I kind of assumed that he was doing something very similar and was also taking the market odds. And then turned up at conference and found out he'd used completely different data, completely different method. I think what I would be interested to look at, as Matt said, if you take his model, then there's so one, I think actually there's some interesting links between some of what Matt was talking about, just on a more statistics mathematical perspective, not an implied sense. Because one of the ways of fitting the Bradley-Terry model is through the Poisson trick, and so you end up with some of essentially the same maths. So I think that's interesting anyway. But I think my takeaway would be, kind of as I mentioned that last point, I'd probably want to do 2 methods using 2 completely different sets of data, and then try and work out what a good mix of them would be. I mean, I think there's been some interesting papers recently. I think it might have been a Raftery one on how you take different models and weight those models in predictive scores or for inference or whatever. So that's what I would have taken, that you could build something based on the goals and something along the lines of Matt's thing, or maybe I just would have taken Dixon Coles off the shelf and used that, being unimaginative, and then use both of them and try to see how you would weight them or how you would use them together.
Sounds good. Matt, anything from you on it?
Yeah, I think personally, I remember going to the conference and just being really wowed by the fact that you could use gambling data. I just never would have thought about using it at all. And definitely, using it to kind of validate predictions from this model, kind of find out if there are any teams that are on a good run of form and are kind of maybe improving quite a lot. I think the gambling data will adjust much quicker than the data from the Poisson model. And so I think, basically just kind of opened my eyes to a whole new way of approaching the problem.
It's good. And actually, there's a good point. And I'd said we were going to do this right towards the end, but I'm going to do it quickly now because I'm aware we've got 10 minutes left. I've got some more questions to ask you. When these guys did this, they did this all pre-tournament. And so what I'm going to do is I'm going to share a tab on my machine so you can all see, because we have a new prediction competition, which you should now be able to see my window. I'm going to put the link in the chat. So when the guys did their predictions, they did them all essentially pre-event. So there's no, like Matt was saying, there's no updating as results came in to kind of say who's better. So they did all this before, and the fact they were able to beat the market and do something that was really good, both in different ways, was very interesting. But what we thought we'd do this year is kind of up the ante a bit and do it again. And both Matt and Ian, they're welcome to join this. And we have a GitHub page for our 2022 Wimbledon prediction competition. So based on what they're saying, I thought I'd just quickly go through this. So big thank you to Smart Odds for sponsoring the competition. The goal of this is to make probabilistic predictions on the outcome of matches from Wimbledon 2022. So you can use any data you want as long as it's publicly available. If you want to scrape it, that's fine. We need to know kind of where you've got it from, and we need to be able to replicate what you've done. So given, unlike when the guys did their 2020 Euros results, they knew all the teams because it was defined by qualifying. You're not going to know this for Wimbledon because people will qualify, people will pull out late. So what we're asking you to do is to make a prediction for every possible singles match between the top 100 female and the male players in the world. So obviously separately, you predict the top 100 females against each other, top 100 males against each other. And what we're looking for is predictions to be made as probabilities for each player to win the match. Now, and I'm going to ask you guys about how long you took on this, because I know there might be a difference in this answer in a minute. Submissions must be made before 10 a.m. on Monday, the 27th of June. That's the first day of the tournament. So you can go right up to the deadline if you so want to. What we need is code and data, or links to the data if the data sets are large, to generate the predictions. So we need to be able to reproduce your results. It's free to enter, and you can either go as an individual or a team, and I'm going to ask you both about that in a minute. And you may update your predictions at any point before the start of the tournament or the end of the submission date. So if you were working on Summer and, the night before it's due to go in, you come up with this crazy good idea and you run it and it's much better, you can update what you're doing. And we will be using the log score to determine who is the best. So that will be the log score across all matches played during Wimbledon 2022. So that'll be some to provide your overall entry. And as the guys said, the prizes for this competition are actually quite good. All winners will be invited to present their work at the 2020 RSS conference in Aberdeen with reasonable travel expenses paid. And you will most likely receive a tacky trophy, which I assume I will pick. Do you have yours to hand, Matt?
I can go get it if you'd like.
It's up to you, mate. It was pretty tacky. I'll leave it up to you if you want to grab it, if it's handy. If you want to make a submission, here's all the details on here, how you do it. We've got an email address, statisticsinsport@rss.org.uk, that you can contact, and one of us from the committee will, yes, nice. That's put that in my suitcase last time. That will get back to you on any questions. And, you know, we're wanting as many people as possible to go in and do this. And it is good. It was good last time. It was good seeing it. The guys are updating it. In fact, I'll stop sharing my screen and I'll put the link in the chat. I'm pretty sure during Euro 2022, Ian, as you said, they're updating it as we went. So you guys could kind of follow along. And whilst that is not my responsibility this time, I'm sure something similar is going to happen. Oh, there are questions in here. Sorry, Colin, I missed your question. I will come back to that. In fact, I'll come back to it more. I've put in there the link to the GitHub page on there. There's also a link to an article that we've got on Stats Live, just for some light reading. And I'm going to ask the guys a bit about them doing it, but I'll ask Colin's question first. So Colin asks, Matt, have you subsequently incorporated home advantage in your model and looked at what difference that would have made? I would like to have done this in my case, but did not have the time.
Yeah, so I guess there's two kind of main ways of incorporating home advantage. So a couple of people kind of do it just by multiplying the probabilities by some parameter, if you know that they're at home. And then you can also do it by kind of having separate parameters. So you can have an attacking strength while you're away and attacking strength while you're at home, and then similarly with the defensive vulnerabilities. And so you kind of, you double the number of parameters in your model and fit it that way. So I've tried it in a couple of models. I was modeling the Premier League just for fun. And it does give you a bit of a difference. So, you know, the effective home advantage is really noticeable. The expected number of goals between pairs of teams, whether one's at home or the other's at home, does change by like maybe a whole goal or maybe 1.2 goals or something like that. But you do then just have less data. You have half the number of games. And it's then even more complicated if you wanted to do it for something like Euro 2020, where in this case, some teams were at home some of the time. And like normally it's kind of all at a neutral venue. So I'm not sure exactly how you'd apply it to there, but it definitely would make a difference to the parameters you'd get out.
Great. I had a couple of quick questions because I thought we were going to struggle to fill the time, but we've got 4 minutes left.
Could I just make a point on the home advantage?
Yeah.
I mean, that might be an interesting way of using the market odds, augmenting those, because obviously in the qualifying matches you have home the opposite ways. You have home and away. So there may be some way of kind of teasing out what the market assesses as the home advantage on average in some way, and using that as augmented data specifically for that purpose.
Great. I was going to ask you both about what you're going to do in this upcoming prediction competition, but you can keep all that now confidential and put your results in, and maybe we'll see you on the podium again. What I was going to ask, just for the benefit of people who maybe are wanting to do this, is the time that you guys spent on it, because obviously, Ian, you worked as a team. Matt, you worked by yourself. What was the kind of time constraints on doing this? Ian first.
So as I said, we got our entry in, I think it's something like, can't see the email, but 7:50 something on the Friday evening, with the deadline being 8 p.m. And we'd started talking about it on the Tuesday. I think I'd maybe had the ruminations of an idea before then. I think I probably spent order of magnitude, I don't know, maybe around 10 hours, maybe not a lot more than that, probably a bit less than that. And there was a little bit, and probably David and Stefan between them, less than that. Yeah, so maybe it was like 15 to 20 hours between us would be my estimation. Probably less. If anything, that's a slight overestimate. So we didn't spend too long on it, I think. But I mean, it's an interesting challenge, right? You can spend as long as you like on these sort of things. So
exactly. Matt, how long for you?
Yeah, I think maybe similar. So yeah, maybe around 10 hours. Kind of. I mean, the model I've been kind of mulling over, I guess, in my head on train journeys and stuff for a couple of weeks before actually getting down to doing the coding. And then it took me a good few attempts to get the code to work. I had Scotland as huge favourites the first time, which was just clearly not right. But yeah, so maybe a similar amount of time.
No, it's good to hear. And I suppose to everyone on this call who's looking to kind of thinking of getting involved, you could win it by not necessarily having a lot of time to invest in just a good idea or something a bit novel. You know, these are two kind of really novel, they're different approaches at solving the same thing. And whilst, like, you know, both of you have kind of alluded to similarities in kind of approaches and the way you've looked at things, you did these independently and kind of got very close to each other in terms of your predictive ability. So it is now 13:29. We've got 1 minute left of this, so it's commonplace for me to just thank you both for coming and doing this.
Could I say just one thing, Rob?
Go on, then.
I wasn't planning on entering this year, but if anyone wants to join me and do the coding side of it, then I'm very happy to join up with anyone. So just contact me. I'm on i.hamilton@warwick.ac.uk.
I forgot you were going to mention that. And obviously I did remember, Matt, you do some work for Oxford City. That's maybe a talk for another time. We'll get you back to do that talk. But thank you both for coming to the conference, 2 excellent talks. And again, for doing those today. Hopefully everyone's found them beneficial. We have got the recording and we will use this to kind of promote what we are going to do with this competition. But it's also there for prosperity, so people can go back and kind of see what you did. So yeah, thank you guys very much. I'm sure everyone's enjoyed this on the talk. Thank you all for coming. It's been really good having you here. And yeah, good luck if you enter the competition. Thanks, guys.